Astronomy has given us close-up images of the planets in our solar system, and while those were all great, none of these planets are as similar to Earth in terms of atmospheric properties as Saturn's largest moon, Titan. The Cassini-Huygens mission was the very first to send a lander to the surface of Titan, and the images sent back opened up a new world of mystery of the moon with rivers of methane. But what did the lander actually capture in those images? Well, we've got all that covered in today's video, where we look at the first and only photos from Titan, Saturn's largest moon. The mission. The Cassini-Huygens mission was one of the longest space probe missions in recent history. Launched in October 1997, the spacecraft embarked on a long 7-year journey on its way to Saturn. The voyage had several detours along the way, as Cassini had to fight against the Sun's gravitational pull, leading to several flybys and gravity assists from Venus, Earth, Jupiter, and even an asteroid named 2685 Massersky. Upon reaching Saturn's orbit in July 2004, Cassini orbited the planet before dropping off its companion, the Huygens lander, in December on its planned entry into Titan's atmosphere. Before the arrival of the Cassini-Huygens mission, not much was known about Saturn, its elaborate ring system, or its diverse moons, all of which was still a mystery. There had been several flybys from the Voyager spacecrafts in the past, but none ever orbited the planet long enough to provide detailed observations. Titan, on the other hand, was even more of a mystery. Being Saturn's largest moon and the second largest in our solar system, Titan holds much promise, as it's the only terrestrial body in the solar system with a dense atmosphere and clear bodies of liquid on its surface, other than Earth. In more ways, Titan is more of a planet than Mercury, as it's larger in diameter, more massive, and holds the atmospheric and ground capabilities to possibly support life. After its separation from the Cassini, the Huygens lander proceeded into Titan's atmosphere by parachuting ever so slowly into the unknown dense atmosphere that shrouds the moon. On January 14, 2005, the European Space Agency's Huygens probe became the first spacecraft to successfully land on a solar body in the solar system's outer region. During its slow 2.5-hour descent into Titan's atmosphere, Huygens captured imagery of the dense atmosphere, which is filled mostly with nitrogen, reacting with other trace elements to produce the dense clouds that surround the planet. Images. The very first images show remarkable features such as incredible shorelines and even river systems much similar to those present here on Earth. Just as the lander emerged from a 30-kilometer drop underneath the clouds, it revealed a surface filled with traces of liquid, but instead of water, the surface was filled with liquid methane at temperatures well below -180°C. The first processed images revealed some forms of rocky materials on Titan's surface, but upon further observation, it was revealed that these were not rocks but frozen ice blocks. These first images revealed these ice blocks filled the landing site and were small pebble-sized blocks no more than 20 centimeters in diameter. The images also revealed that Titan's surface was much darker than originally expected, with the thick atmosphere deflecting much of the sunlight from entering the moon's surface. The observations indicated that they were evidence of some forms of erosion, which confirmed that there was indeed fluid activity, which most likely occurs seasonally on the moon's surface. Huygens appeared to have landed on a dry riverbed, which probably contained a mixture of hydrocarbon ice and water, which scientists believe flows at some point, but freezes back up for most of the year. The soil composition of Titan appears to consist of mostly precipitated deposits or rain from the nitrogen clouds that engulf the planet. A composite study of the images also revealed that atmospheric nitrogen results in the formation of ethane and methane clouds under the heavy organonitrogen haze. This forms a unique climatic system that results in wind and rain similar to the atmospheric conditions here on Earth. Precipitation and rainfall leads to the formation of lakes, rivers, and dunes, mostly filled with liquid methane on Titan's surface. With a large nitrogen atmosphere resulting in subsequent liquids, Titan has a rather peculiar methane cycle that has a striking resemblance to Earth's water cycle, although Titan's methane cycle occurs in a much lower temperature of -180°C. These dark areas seen in the images are dark materials that have been washed off from high elevations by the methane rain and have concentrated at the bottom of ravines and drainage channels, much similar to ponds and aqueducts here on Earth. These mosaic images provide an unprecedented look into the ridge and hill formations on Titan, resulting from the flow of liquids from different angles. Images analyzed from Huygens' DISR instrument show the striking similarities between Titan's geological processes to Earth's. A look at the images shows that the contrast between flowing rivers of methane results in the formation of shorelines, beaches, and even islands, which are remarkably similar to those found on Earth. These images prove what scientists have believed to be present on the surface of Titan, which is a complex network of drainage channels resulting from the constant flow and evaporation of ice and water. These composite images were taken during the probe's descent at an altitude between 13 to 8 kilometers, while it made its way towards its landing site. They show a clear contrast between the lighter-colored upper terrain and the darker-colored lower terrain, which are filled with accumulated methane and other organic materials. The images show a 360-degree angle around the probe as it made its descent, with the white streaks seen in the image attributed to being fogs of methane or ethane vapor rising from the liquid surface below. In addition to observing the surface properties of Titan, the probe also took some readings of other atmospheric features, including wind speed, which was estimated to be around 6 to 7 meters per second. Cassini's observations. While Huygens took images from Titan's atmosphere, the Cassini space probe also carried out radar imagery of Titan while orbiting Saturn. The space probe provided weather imagery, which scientists were able to use in producing a composite map of the methane distribution across the Moon. The images revealed that most of the methane lakes and seas were concentrated close to the North and South poles, where extremely low temperatures prevent evaporation. Titan's largest body of liquid, known as Kraken Mare, was imaged by Cassini in 2006 and is measured to be slightly bigger than the Caspian Sea here on Earth, making it the largest lake in the solar system. Further imaging and reflective radar analysis revealed that the distribution of methane lakes on Titan was not just restricted to the surface, and they had depths of well over 200 meters. To put this into perspective, Titan's largest lake could fill Lake Michigan 5 times over, with enough methane left over to fill the Mississippi River. During several flybys by Cassini, it was revealed that Titan is seriously warped by the constant gravitational pull from Saturn. Analysis of the data suggests that the surface of Titan can rise and fall by as much as 10 meters, resulting in its relative position to Saturn during its 15-day orbit around the planet. This finding, provided by Cassini, indicates that Titan is seriously deformable and subject to gravitational warping by its tidally locked host, Saturn. The imaging also indicated that Titan could be hiding a vast global ocean of water underneath its thick surface, and its atmosphere is filled with prebiotic chemicals that could form the basis of organic life. Scientists believe Titan's current state is much similar to Earth's billions of years ago, before the first chemical cells formed, and it could be a planet-sized laboratory to study the prehistoric chemical reactions that led to life as we know it. According to scientists, the Cassini-Huygens mission was far more successful than anticipated. This is because not only was the probe able to make a successful landing, but even though its lasting impact was greater than expected, the lander didn't sustain any damages and maintained communication without any glitches. Furthermore, the lander was able to maintain communication with Cassini for an outstanding 72 minutes before contact was lost with the space probe, while the Huygens lander completed its mission in just under 4 hours after entering Titan's atmosphere. Cassini continued on a long 13-year observation of the Saturn system. Over that time, Cassini was able to complete 127 close flybys of Titan, revealing several atmospheric and surface features from the Moon/planet. With Cassini's help, scientists were able to deduce that Titan also has weather and climate patterns, with several vortex clouds as well as methane rain observed over that time. Cassini reached the end of its mission in 2017 and was launched into Saturn's upper atmosphere, where it burned up to prevent external contamination of Saturn's moons. Do you think Titan could be the next solar body to birth life in the solar system? Let us know in the comments, and we'll see you in the next video.